I am joined by Dimitris, but before we dive into that, just a little bit of housekeeping stuff, I guess. So our upcoming event is Nodes. The Neo4j Online Developer and Education Summit. That is a virtual event and completely free and is packed with 24 hours of amazing content. It's probably my favorite event every year. And that will occur on October 26th. So if you're not registered to be part of that event, I would definitely do that. So check out some links and stuff around for that. But without further ado, let's talk to our guest here because that's why we're here today. So we have Dimitris on the call today. He lives in Greece and has a PhD in pure mathematics. The last 7.5 years or so, he has been working as a consultant with a specialty in data and analytics. In his free time, he enjoys family life and tries to keep up with what is happening around machine learning, AI, and data in general, which from my perspective is a very large undertaking, I think, especially recently. You can find him on socials for LinkedIn and Medium as well. Those links you'll have access to if you want to follow his content and check that out. But today, what we're going to talk about is his article that was published on Medium under the Towards Data Science publication, talking about movie recommendations with Neo4j. And he'd like to focus on how users can leverage Neo4j to quickly build a recommendation tool. So welcome, Dimitris. I will hand it over to you to talk about the project.
Yeah, thank you. Thank you very much, Jennifer, and thank you for organizing this and inviting me to speak for the opportunity to share.
We're very happy to have you.
So I think that without any further delays, I should start and diving into the practical stuff. Everybody from the audience is free to ask questions. I'll try to keep up with what's happening in the chat, and I'll try to answer them if they are relative and I can while I'm presenting. Otherwise, we can probably have a Q&A session in the end.
So, yep, sounds good.
Let me share my screen. And I don't know if. All right.
There it goes. We can see it now, I think.
Great. So to be perfectly honest, the recommendation model that I'm going to be presenting is really simple. So, and that's because I was just trying to create a simple exam using graph databases and Neo4j in special. So yeah, it's nothing very special. Creating a recommendation engine or a movie recommender system in special is a very complicated work, and it involves too many steps. Here is just a simple example that one might be able to use it as a baseline model. And furthermore, it is an example that showcases how easily you can do these things using Neo4j. For this example, I have set up a sandbox, Neo4j database in Neo4j sandbox, and I'm also be using going to be use Colab, Google's Colab, and the data is from grouplinks.org. So The first step is to install the necessary libraries in Python, and I have done this. Next, the next step is to, of course, load the libraries, have a connection. For anyone that is worried that my password is on the screen, the sandbox is going to expire today, so I don't believe that there is any problem. And just checking, currently we don't have anything in our databases. So the next step is to load the data that we are going to use. And it's consisted from 3 files. One is a file that contains movies, have a movie ID, title, and the genre of the movie. The second is users data file that has a user ID, the gender of the user, age is encoded. For example, in the first line, the actual age of the user is not 1 year old, but yeah, it's just in the first bucket of ages. Occupation and zip code, we are not going to use any of this, and just the user ID. And the third file has the ratings of the movies by the users. So we can see, for example, that user number 1 rated movie 1193 with 5 out of 5 at a given time step, and the movie 661 with 3, and so on. The first step, after we have the data loaded in data frames, is to upload in the graph database. So first we upload the customers, and we are creating for each we are updating customers / users. For each user, we are creating a node that also has the gender and the age encoding. Next, we upload the movies, and for each node, for each movie node, we have a title and the gender that the movie belongs. And finally, we update the ratings, and this is in the form of relationships. So if a user has rated has rated the movie M, then we just create relationship connecting the two nodes, U and M, and we add the rating as an attribute of the age. This will take, I'm afraid, a little time, because since we had a lot of movie ratings, we have to use we have to split the data in chunks and upload it. Otherwise, when I tried to upload the whole file in one go, I encountered some connection issues, and that's why I'm splitting the file into chunks and uploading its chunks separately.
Yeah, that was actually one of my questions was how did you realize you needed to break it into smaller chunks and load it that way? But I guess it looks like you might have had connection errors and things like that that kind of hinted that this is too much data to push in all at once.
Exactly. Exactly. I'm afraid I'm not that well versed to this stuff, so it was mostly trial and error. In retrospect, I should have expected that, but yeah.
Sometimes you don't know until you try something.
Yes,
I run into that
yes,
stuff
that's
still,
true.
so yeah, not a problem there. Okay.
That's true. So the schema that we have is a really simple one, just user nodes and movie nodes and a connection, a relation with the name rated. All right, let's see. And yeah, the most easy way to create a recommendation given a movie uh, is to just count how many paths there are connecting the movie to the left, to other movies to the right. Let's say that you are given a movie which is represented by the node on the left, and you are trying to figure out which movies are more similar, or someone would recommend uh, to a user that has viewed the movie to the left. The simplest probably way is to just count how many paths you have connecting this movie to other movies, and then just suggest the movies that are connected with the greater number of paths to the original movie, to the movie on the left. So let's see whether this. All right. It's almost completed. And to answer the question about whether we can, by using the Google Colab, we can see the graph. The answer is that I'm afraid it's not that easy. In this case, I have just copy-paste the image. I took it from Neo4j, just copy-paste. I know that there are some Python packages for adding and creating graphs to Jupyter notebooks. To be honest, I haven't tried them. And I'm afraid that even if they work, they won't display all the information that we have here. So, for example, how many the node labels and the relationship types, and I haven't seen something that is able to do that. Maybe there is, but and I have missed it, but I don't know. So
I can share the GitHub link to your repository, though, correct?
Yes.
Okay, because
yes,
that you can actually see. You have the option to open it in Google Colab, but you can actually see the results of that as well, just in GitHub.
Yes, that's true. But I'm afraid it's just an image that's embedded in the node. It's not something that's created by the code. So now that we have everything, let's see just a simple count of the nodes, and let's update schema visualization. So everything is working as expected. And so, as we discussed a few minutes ago, let's say that we want to suggest movies that are similar to Toy Story. And the Cipher query that we would use is this one actually. And what it does is it searches for paths that connect the node that corresponds to Toy Story to other movies. And we also have an extra filter here that the rating is 5, meaning that the user should have rated Toy Story with 5, excellent, and also the other movie with 5 stars in order to count the pass. And so let's execute it. Here we can see the results. A comment here is that maybe the results seem a bit old, and maybe they are. And there are 2 reasons behind this. The first reason is that in this case, in the example that I'm showing here, I'm using the 1 million ratings dataset, which is not really big. If someone goes into grouplens.org and downloads maybe 10 million dataset or an even bigger, the results will be better here. Because to be honest, yeah, Toy Story is right. It's related with Toy Story 2, but I'm not certain that it's that a close match with Star Wars. Maybe it is, maybe it's not. But, all right. And of course, keep in mind that we have just used a very similar logic here. And this is one of the things that I'm trying to showcase here, is that with a simple query, one is able to provide recommendations. All right, and we can also create a parametric query where we can insert as a variable the movie that we want to find recommendations for. So for matrix, we get this, and you can see that we again getting Star Wars as a result, and also Raiders of the Lost Ark, and even this movie, and one of the other reasons that we are getting again more or less the same movies is that this method is affected by the popularity of the movies. The more popular a movie is, the more probable is that we get it as a result from this method. This simple method, I'm afraid, is biased towards more popular movies. Okay.
Right. The more diverse and bigger that your graph is, the more it's going to kind of find other options and other paths into other things. So that's one good thing about more data. And more data.
Yes, and of course, one could play with this query and maybe alter the values here for the ratings, or maybe even go to keep to even further and taking into account more paths, longer paths that connect probably, and also that connect movies and through I don't know, starting with the movie that we want to find the recommendations for, going to a user and then to another movie and then to another user and then to a third movie. And yeah, of course, one is able to do this very easy with Cypher, and yeah, maybe even take into account some weighting. average of the ratings. All right. And just to showcase how more easy is to do things with Cypher, and a common question that I have heard a lot is why one should use graph databases and Neo4j, and why just not use a simple SQL database. The answer is yes, yeah, you can, but it's far more easy and efficient to use graph database and Neo4j for some problems than a simple SQL database. And here you can see that this is the query that we are using to recommend movies for Toy Story, and what a similar query should be if we had a table like this in a single SQL database. And by the way, if I have any typos in here, please forgive me. But yeah, I haven't. This is just a dummy code. It's just to explain the differences.
So how did you get introduced to graphs then? Did you come from did you know relational before, or did you work with a lot of other types of NoSQL databases, or?
That's a good question, and I'm afraid I can't really remember. I know that Neo4j has been around for several years now,
Yeah.
and yeah, back somewhere back in time, I just heard of graph databases and Neo4j, and said that to myself that I should yeah, give it a try.
Nice. Well, that's great. Kind of a curiosity then. It's like, oh, let's try this.
Yes, yes, and maybe my mathematical background has something to do this. I mean, graphs. Yeah.
Yeah, very much
a nice mathematical object.
right. Yeah, very much based in mathematics, but have a lot of other uses and crossover too. That's really cool.
Yeah. Yeah, and also now that I'm checking the chat, there is a comment about cleaning data. Of course, before one uploads data to a database, should always clean them before. As I said, this is just a simple example, and yeah, as far as I have seen, the data files that I've been using are clean enough for our purpose here. Probably one should have splitted the channels here, and I know for a fact that there is a nice course in Neo4j that does this a similar thing for a graph that also contains movies and recommendations. I remember that I have seen a course in Neo4j's site where this field is split, and new nodes are created for a new node for its different genre, and then connected to movies.
Was that the Graph Academy data import course, maybe?
Probably.
Okay.
Probably. I'm afraid it's been a while since I I've took this course, and I'm afraid I can't really remember. But I remember that there is a course where it shows how to split this into 8 different nodes.
Yeah, that's something I use pretty frequently too.
So you are far more experienced than me, and probably you are right about the the force. Okay. So another way that we could use graph databases to provide recommendations is to use zard similarity. And for example, if we have this similar graph, what is the similarity index calculated for nodes 1 and 2? The similar description is that you count how many edges connect the two nodes that you want to find the similarity of, and then you divide with the number of different edges that are connected to the nodes that you are interested in. So in this similar example, we have just one edge connecting nodes 1 and 2, and in total we have 2 edges. Hence, zard similarity between nodes 1 and 2 is 0.5. And what we could do in order to recommend movies is to use this zard similarity to create a new relationship between the users, and then we could calculate an average rating using zard similarity as weight. And now I think that I have done a mistake, and it will not, it will not run, but yeah. So in order to calculate similarity, you have to do create a projection. I believe that, yeah. And here I'm getting an error, and this is because I have already created the projection in my database. So that's why I'm getting the error. I should have deleted the projection before. Let's try this. Okay. All right. And now we are ready to create a new relationship. And I'm afraid I cannot fully understand the question about mathematical matrix and sets. So if I could get some more details about the question, maybe I would be able to answer. well, while we are waiting, maybe I can, I can go over to the notebook and use what's already saved. And as I said, in order to provide recommendations, one is using the zard similarity. We just examine paths. Let's say that we have user one, and we examine paths where the user is connected to another user, and the second user has rated a movie. And what we do is we multiply the similarity between the users and with the rating of the movie. And then we just divide with the sum of all the similarities of the users that we have found that are connected to user one. And what I have done after experimenting a bit is that I wanted to also have a way to boost movies that are connected more often to user one through this way. And that's why I added the logarithm of the number of paths that we have. That's just a simple trial and error on how to optimize the results. All right, so we have created the similarity. For example, the user 4,725 and the user 4,808 are 0.75 similar. And then we just create a new relationship between users this time, right? Which I believe that we will be able to see now here. Okay. So for user 4,725, the recommendations, the first 10 recommendations are these movies, and what the user has actually rated them is 5 star. 5 stars is displayed in the next cell. So I'll try to zoom out. Yeah. I think that we are pretty good given the size of the dataset that we are using. We have a lot of action and sci-fi science fiction films.
Yeah,
that are recommended. Yeah, sorry.
I know that those look like really good results, actually. So that's pretty cool.
Yeah, and as I said, it's just a very simple software query and a really small data set. I mean, usually in order to get better results, one is using the 10 million or 25 million ratings data sets from films.
Okay, yeah.
So I'm afraid that that's all.
Okay.
from me.
What would you
Just a simple example.
Yeah,
Yeah.
what would you recommend for somebody getting started? Would you recommend something like a, sandbox and just some kind of play queries, or how would you go about helping other users do something like this?
Uh, Definitely going in to Neo4j site and checking the courses. And what works for me at least best is getting my hands dirty and trying comes to figuring out problems that I encounter while I'm trying to do things. So yeah,
Right.
maybe the best way to do this is view some of the courses and then try to create something using a Neo4j sandbox and a tool like Google's Colab. And I'm saying this because it will save one from all the trouble of installing software. Like
Yeah.
this, you don't even have to have a Python in your machine. You can execute everything from the cloud.
Yeah. Yeah, that's really cool. Um, did you come across any challenges or any tricky things that kind of were difficult to overcome?
Uh, well, to be honest, it's been a few months since I've done this, and I can't remember. I know for certain that I encountered several problems, and of course, we already said that the idea to split the upload of ratings in forms of relationship, yeah,
Yeah.
came from the simple fact that I failed to do this in one go, and then I had to go in and figure out how to split it and do.
Yeah, data import is always a hassle, right?
Yes, yes, yes. That's true, and not only for Neo4j, but
Yeah.
for everything. And yes, then the other things are that I have a difficult with is the creating the calculating similarity, because to be honest, I'm just yeah, mm, yeah, not that much experience with creating projections. So yeah, I think that yeah, it took me a long time, but yeah, I didn't get it right with the first try.
Yeah.
And then it's yeah, about adding this term in the query.
Okay.
I was first in my first attempts. I just yeah, had the rest of it, and then I saw that uh, after examining some examples, I have seen some yeah some results. I noticed that I should also, it would be nice to also take into account the number of paths. So I thought about adding
Okay.
this term. It's more for me. It was more trial and error and yeah, experimenting.
Okay.
And
Yeah.
maybe that's the reason I started doing this single example.
Yeah.
So I see a question about running Cipher. Well, in a Neo4j browser, yeah, you can do both. But if you, in my opinion, if you need to have a graph database Neo4j somewhere, and then calculate the results and fit these results to another calculation or another model, then I believe that the best way to do this is to do in with Python programmatical at least, not Python or whatever language one is using. and not use Neo4j browser. But yeah, that depends on what someone is trying to do. Neo4j browser is an excellent tool, but yeah, if you are thinking about making something that's closer to production and being executed automatically, maybe I would go for using a Linux.
Yeah, that makes sense. Okay.
So I don't know whether there is something else.
Yeah, I don't see any other questions right now. Did you have anything else to cover, or?
Let's see, one more question just
Oh,
came in.
you're right. So the question is, if we have a big data set with a lot of columns, how do you get to the specific target fields to connect the relationships and visualize it?
That's a tricky one. I believe it has to do with how you create a database schema in general and what fields to use. That's a really tricky question, and it's not just related to movie recommendations or graphs. I believe that one should start by thinking really hard what he or she is trying to achieve with the data, and then how what information is really necessary to get to the results that one has in mind. And to be perfectly honest, I'm afraid that in most cases it would also involve some trial and error, I think, and several iterations until you get this done correct in the way that you want. And of course, if we are talking about big organizations, there is always the case that you have set up a database, whatever database this is, simple SQL database or graph database or whatever. And then after some years, probably there is a new need, a new data set that you have to ingest in your database. And so, yeah, it's back to the drawing board, thinking about your database schema and how to add new information to it. And of course, there is, after you figure out what you need to add there is a whole, a lot of steps, quality checking, cleaning, so the simple answer to the question is, depends on the case, on what you need to achieve, and yes, I'm afraid it's also trial and error.
Yeah, how did you decide, maybe it's kind of a follow-up, how did you decide you wanted ratings on the relationship rather than sticking it on a node somewhere? And maybe a tougher question than what it sounds, but
To be honest, that seemed the natural way for me to do it. I mean, I can visualize the user as a node and a movie as another node, and the rating is just something that connects users to movies. I mean that,
yeah, that seems sensible.
maybe, it's just me and a curious way of thinking. But, and
No, I think
be
that
honest,
feels
I think
natural.
that I have also seen that before, so maybe I'm a kind of biased of doing this way and having ratings as a relationship rather some other way.
Yeah.
Yeah. So
Okay. Well, this was a really interesting project. Thank you so much for kind of sharing your process with users and kind of walking them through this as well. So hopefully they can create some really neat projects.
yeah, of course, there is a huge room for improvement. I mean, we haven't used at all information about jingles, and we haven't used at all information about our customers. I mean, one could also use the age, occupation, and the gender, the user demographics. Sorry, I'm referring to users as customers. Sometimes it's a habit from other projects. So
Okay. Yeah, so there could be some more opportunities for kind of continuing on this and doing some other things with some data we haven't touched yet.
yes, definitely, definitely. Absolutely.
Okay. Well, we'd love to see more content from you.
Yeah, I'll try to create something more because this is a really interesting exercise and trying to create a movie recommendation system that it's uh, good enough, let's say.
I've definitely learned a lot. So thank you very much.
You're welcome, and again, my pleasure to be invited to your event.
We'd love to have you back. All right. Well, I think that's pretty much it for today. Thank you all for joining. We hope to see you on the next installation of Neo4j Live next month. Again, if you have not seen Dimitris's article, there we have a link to that from the Towards Data Science publication on Medium. However, it is kind of blocked if you're not a subscriber to Medium. So Dimitris is going to see if he can get a free, openly accessible link to that, and we'll try to get that out to everyone. If anyone thinks of anything else, feel free to ping Neo4j, or if you connect with Dimitris directly on LinkedIn, feel free to do that as well. And thank you so much for joining, and we hope to see you guys again soon.